Hey guys, welcome back. So in this second episode of Learning Design Principles, low-level design patterns, we'll take a look at observer design pattern now, and we will learn it. And this is going to be a part-packed session where we will take a look at problem, we'll take a look at naive solution, and then we'll take a look at how observer design pattern will come in and help us to solve the problem. And also we will take a look at the fourth design principle in this series we are learning. So in the first episode, we discussed three important design principles we should take care while we code any solution. And in this observe design pattern, we will take a look at fourth one. And also observe design pattern follows all the four design principles. So let's get us started. I've prepared a presentation, so let me share my screen. Okay, so what we are going to take a look at. So it is the most commonly used design pattern. So this is going to be used when we have notification. Basically, we want to notify several users, or let's say several products or several objects that some state has changed and you should know about it. So, what are examples of it? Examples can be seen in our, let's say, in our basic notification architecture. So, let's say I have an application and I want to notify 10 users about, let's say, a new feature, or let's say new news coming in. So, whenever we want to notify this n number of basically subscribers who want to listen to this news, this is where the design pattern will come in and help us. We'll discuss it more in coming slides. And it has one-to-many relationship. As I discussed, we will have one notifier and multiple listeners of that notification of any state change or any updates. And also we'll take a look at the power of loose coupling, how this will help in our design design solutions to be flexible and resilient to change, right? And also we'll go into a little extra. This is what I've prepared for you. So this is what a little tip of the iceberg where we'll discuss which pull or push mechanism we should use for getting the state for the notifier, basically the listeners of the notification. So we'll take a look at the problem. So we need to design the weather station. So what the weather station will look like is, so the weather station will have the values of temperature, humidity and pressure, right? And it will it gets updated in real time. So this weather station gets updated in real time. Now we have our weather data object that this weather station calls to basically whenever it gets updated. So this weather data object gets updated in real time also. And now the job of this weather data object is that it has to notify. Basically, it has to basically maintain a display, right? So it has to we need to implement several displays of this humidity, pressure, and temperature. So using these three values, we need to implement several displays like what are the current condition weathers, what is the forecast of the weather, and let me show you a diagram of it. So what we are going to basically take a look at. Right. So this is what I discussed. Let me zoom in a little bit. Right. So this is the weather station. It's a complete black box to us. Consider it as it knows it is attached to sensor devices for humidity, temperature, and pressure. And this weather station gets updated in real time whenever either of any values get updated. Now this weather data object, what it does is it pulls the data from weather station, like get me the humidity, temperature, and pressure. And the job of what's the job of us as a developer is we need to implement the solution where we will implement three displays, and what the displays will be current conditions display, and there will be weather stats display and also forecast. So also the displays need to be updated in real time. So let's say whenever we get a new value of humidity, temperature, and pressure in this weather data object, or it gets notified, we need to basically update these displays also in real time. So whenever we get a new state of this values, we need to update the state of this displays also, or let's say the view of it. So our job is to, if you see, we are provided, or let's say if any future displays also come, we need to make our code flexible for it. So if you see, we have this weather data object. It deals with getting the data and notifying the displays, basically pushing these changes to display, right? So this weather data class has four methods. It has get temperature method, get humidity method, get pressure method. These are getter methods for the state it is maintaining. This weather data object is maintaining state of temperature, pressure, and humidity. And it also has this method measurements changed. This is what we need to implement. So we will implement this method. So the basic solution which comes to my mind is like, if I have to implement measurements changed, uh, what I will do is, let's say there is a update method to this display. I will just call like this, right? I will just call that display one dot update, and then pressure, temperature, and humidity. Similarly, if I have to update display 2, I will update this P, T, and H. This is how we will try to implement this method of measurement change. So this is what, if you see, I have here mentioned a misguided implementation or the naive solution we're going to be discussing, right? So here, if you see, we have this weather data class. If we take a look at, we need to implement this measurements change method. Our job as a developer is now it has these getter methods which knows that in real time what my values of temperature, pressure, or humidity is. So once we get the real time values of it, what we do is we update the display one, that display one, I've got new values, you also update it. So it calls the display one. It calls display two again, that I've got new values, you also update it, and then I have display three. So it also calls the display three, that I got new values, you also update it. So this looks simple, right? This is an easy code if you see, that what's the big deal in this? Like, what's the problem in this? So if I come to the problems here, there are many things which we need to take a look at we are doing wrong, or let's say that can be issues or that can be improved. So here we are coding to concrete implementation. We are coding to concrete implementations and not interfaces, right? So if you remember from my first lecture, where I've say shared the first design principle, that second design principle, that we should always try to implement to interfaces, not concrete implementations. So here, if you see, basically we are calling concrete implementations of display one, display two, display three, right? So we should not do that. Rather, we should try to use a common interface for these displays. It should have an update method, and then try to use that. And second problem is that, let's say in future, or let's say in future scenarios, we come up with a problem statement that we need to add new display elements. Then what we will need to do is we will need to come here and then we will need to write here display 4.update. This requires maintenance, right? We are not encapsulating what we are changing, right? So this we should try to avoid. So also, uh, we have no way to add display elements at runtime. So this is a bigger problem. So currently, this is what is hard coded. These are hard code implementations. So let's say in runtime, if you want to remove any displays, or let's say if you want to add any displays dynamically at runtime, like something like this, like add display here it will pass a instance that I need this display X to be added to the list of these receivers of notification. So all this we cannot do in real time because these are with this we have hard coded. Also, we haven't encapsulated what changes, right? This I mentioned that this is the part which is changing. Why changing? Because what are the things that can change? The first thing that can change is what is the state, right? State. So here, temperature, humidity, and pressure. So these are the things that can change. Then second, there is what can change is number of displays. So also the number of states can be changed if we see here. Number of states can also be changed. So this is what if we take a look at our first design principle, which states that we should always encapsulate what changes and we should try to separate it from what stays the same. So this is what is staying the same, but this is what it is changing. So we should write some way to encapsulate it, right? So here these are the changes. So we'll need to figure out how can we try to encapsulate all this. Like let's say in future, basically let's say now comes a requirement that we no longer have pressure. Then we will have to come here. Then we will have to delete this. Then we will have to change the signatures of functions in this method also and in the receiver end also. So this looks very stagnant or let's say not flexible. So to deal with this, we have basically will come to observer design pattern. This is where it will help us. So if we go to we state the definition, the observer pattern defines a one-to-many dependency between objects so that when one object changes state, all of its dependents are notified and updated automatically. Right? We have one subject that is our weather data class, and we have multiple observers, basically the listeners or which are waiting for the new state or display. So these are our displays. So let's see how we will use this. Okay, so I will now jump back to this example of what the definition means, right? So consider the scenario that we have, let's say, some state like here. State means, let's say, we want to notify all these animals that the water is now available, or let's say the water quantity is has increased and you can consume, or let's say uh, they want to basically be notified of the some state change in the quantity of water. So here we have water as a state hour. It's a state, right? So this subject, this is what the source of the state is, and this source sends the state to dog object. Also updates the cat object. It also updates the mouse object. It also updates the duck object, right? So we have one-to-many relationship, right? We have one source which is sharing in basically updating the all the observers. So the terminology in observer design pattern is the subject is the one which is holding the information, and its job is to update the observers. And the observers are will what the job of observer will be basically to get register that I want this information of this new state, and once it registers that I want this state or I'm interested in this state, it will basically whenever now new value comes in or real time value gets updated, it will get notified of it. So let's say now basically let's say now this duck object is no longer interested, right? Duck object is no longer interested that I don't want to be notified about this water quantity. So what it will do is it will be just uh, removed from the observers list. So this observer, this subject will have some method that I want to. It will have methods like register, remove, register observer. It will have methods like remove observer. So what this means is, so whenever this duck object needs to be removed, it will call this method on the subject that I want to be removed from the list. So after that, this duck object will be removed. So this dependency will be removed. And now this duck object is no longer in our uh, list of observers. It is isolated. And now let's say a new object comes in and he wants to be notified about this real-time value changes. So what he will do is, let's say duck is now again after some time it is says that I'm missing on this, is getting FOMO, that I'm missing on this updates or notifications. So he's now interested again. So what he has to do is to be registered, basically to get notified. The steps it needs to follow is firstly it will have to register that I want to be now notified. So once it calls the register method, it will be notified, basically added to the observers list the subject is maintaining. And once this is done, anytime now, let's say any new value comes, the duck object will be registered, basically happy in the happy state. So I hope you got the idea that we have one subject, it maintains a list of all the observers, and it has them, and whenever a observer needs to be get added into the list, it will call the method of register observer that I add me to the list that subject is maintaining, that so that in future I will also be notified of the changes. And if it is no longer interested, it can call the remove observer method. And this is how we can dynamically in runtime change the number of observers and the state. So here, if you basically if you see here, we will now take a look at the class diagram of how subject and how observers are basically like how its class structure looks like. So if we come to the basically we will define interfaces, right? So we first talked about we will have an interface rather than coding to hard basically implementations, so that we can dynamically change the number of observers, and they are basically loose coupled. So in the subject, we'll have method register observer, which registers a observer and it adds to the list of the subject is maintaining, so that in future any updates the subject receives in real time, this observer will also be get updated. Similarly, we have remove observer. Whenever observer calls that method, it will be removed from the list. So, we have notify observer. So this is the method uh, basically where we will notify all of our observers. So whenever our subject receives basically a new value or let's say real-time update that the pressure, temperature, humidity is changed, it will call this method notify observers, and then it has the list, and then it will iterate on the list, and it will call this method update. Why it will call update method? Because this subject knows that my observer, which I'm maintaining the list of, it implements this observer interface. And if it implements an interface, it knows for sure that it will have this method update. So if we to take a look at this concrete, basically implementation of this subject, it will implement this register observer method, which where it will what it will do is it will have an array or list, and it will append the observer at the end of the list. Similarly, remove observer, what it will do is it will remove it from the list which we are maintaining. And notify observers, we will iterate on the list, and we will call for each element on the array, or let's say each observer on the array, this update method, right? And then concrete observer, it implements observer interface. It basically implements the update method. And then in this update method, it can update the basically it will get the new value, or let's say updated real-time value of the state it is wishing or listening to. And it can have other observer specific methods here. Similarly, there can be helper methods for this concrete subject like get state, set state. So this means that if I want to get the temperature, get the, or let's say any state, get temperature, humidity, pressure, they are states. So if I want to get the values of that, I can just call this helper method. And similarly, if I want to set the values of it, I will just call this set method. So if we take a look here, our design is very flexible, right? So my subject, or let's say my weather data class here, this was our weather data class. If we make this as our subject and this displays as our observers, you can see that now my subject doesn't need to know about the concrete basically implementations of displays. Like it doesn't care, or it doesn't have to know about like whether it is current display, or whether it is weather state display, or whether it is forecast display. It just knows only one thing, that it implements observer interface, and that observer interface has method dot update. That's all. He doesn't care, or he doesn't really know about what's the concrete implementation, or what's the concrete user of this observer, or let's say display. So this is very flexible. Also, it is loose coupled. Loose coupled. Why? Why loose coupled? Because our subject is not aware of the detailed implementations, and this is very good to have in design, because if you have loose coupling, if you make a change on, if we let's say if we add some methods or changes in our observer, it doesn't affect our subject. Or similarly, vice versa. If we make changes in our subject, it doesn't affect the observer, except we don't change the interface. That's all. They have to accompany the interface. So this is very powerful, and but we will get into the details now. Let's get into the details of loose coupling now. How this design can help us with what is loose coupling, and how this design will help us. So the power of loose coupling. This is our fourth design principle, and this says that when two objects are loosely coupled, they can interact, right? We are calling from subject, we are calling dot update method, but they typically have very little knowledge of each other, right? Because our subject have very little knowledge that it has dot update method, that's all. they don't know any nuances or extra things. So it gives us a lot of flexibility. And observer pattern is a great example for loose coupling. Benefits. So we'll take a look of the benefits of loose coupling now. The only thing subject knows about an observer is that it implements a certain interface, the observer interface. Right, we discussed this. We can add new observers at any time because on the subject side we have a list, and on the list I can in real runtime I can just call dot add observer dot remove observer, register observer, remove observer. Then third benefit is we never need to modify the subject to add new types of observers, right? So in previous implementation, or let's have a naive solution or misguided implementation, we need every time we want to basically add a display or let's say remove a display, we need to go into the code, write code that dot update and change. That is not very good solution. Uh, Now we can also number fourth is we can reuse subjects or observers independently of each other, right? So these are subjects and observers. They are just not for the use case of this. They can be used apart from the basically from this use case because they were just using an interface, right? So they are not exactly fully basically created for this purpose only because they can be removed as an observer also, they can be registered as an observer also. So once they get removed, they are no longer using this, they are dependent on subject. Also changes to either the subject or observer will not affect the other, right? So this we discussed. So these are the benefits. Now what the fourth design principle says is that we should strive for loosely coupled designs between objects that interact. And what this will help us is with is it will make our designs more flexible and it will make our designs more resilient to change. Why resilient to change? Because our they just they are implementing only interfaces. Now whatever other methods our concrete classes has, they can add remove anything except they just don't basically change the interface. That's all. So this is our power. Now let's design the weather station where we needed to basically uh, update the displays in update the displays of the three station, basically current display, uh, forecast display, and also let me share here, or also any other feature display that comes in. So this is what the class diagram of the observer design pattern looks like. Now, if we come to designing the weather station, it will be similar to our pattern because we are using that pattern. So we have a subject interface, we have an observer interface. Our subject, yeah, basically our concrete subject here. This will be our weather data object, which we showed here. This one. So this is our subject. So this is our concrete subject. It implements these methods, and yeah, here it implements this method. And on the observer end, we have the displays, concrete displays, which are implementing this observer interface, right? We have this stats display, current conditions display, and there will be a forecast display. So if I zoom out a little bit, or also any new display that can come in, uh, if it has to become a observer, right? It just needs to implement the update method. Now, there is also a display interface. So, our displays, they will implement a method called as display. And all they will implement this method display so that it can implement this display element interface. So whenever we get new values via this update, basically observer gets a call to update method. It will make a call to display so that it can make necessary changes to the display, because users are viewing on their devices basically some basically formatted value, basically design of the state, like the current temperature is this, so if you are excited, do check out my website or something. So they have formatted it. So to format or say, let's say, update the display, we need to have a method for it. Similarly, our stats display will also implement the display interface, so it will have an own version of its display method of how they want to display the state. Similarly, forecast display will also have its method, will also implement the display interface. Similarly, any new display coming in, they will also have to implement this display method so that they can implement this interface. So now if we take a zoom out and how the workings will be. So we have this our concrete subject, which is our weather data class, right? So it will have a array of observers that are wishing to be basically get notified whenever new value comes in of state of, and our state is pressure, temperature, and humidity, right? So now how we will implement this displays is uh, where in the constructor, or let's say when we initialize this concrete classes, we will in the constructor we will say that please register me to this concrete subject. Similarly, stats display will also say that, also call the method of register observer on subject, so that they'll be added to the list of observers that subject is maintaining. And whenever this notify observers method will be called, this will call the update method on the all the classes. Like it will firstly call on this, then it will call this, and then it will call this. And this update method internally calls a display method so that they can update the display. So this is how the diagram is. Now let's take a look at how the implementation will look like. So we will take a look at the code now. Let me pull out it. 1 second. Okay. So first, let's start from observer, right? So let's first take a look at subject. So how the subject interface will look like. Let me zoom in. So we will have our interface subject. It will have three methods. Register observer. It takes in an observer instance. Similarly, we have remove observer. It takes in an basically an instance that has to be removed from the list. And similarly, notify observers, which will call all the update methods of the observer. And now, if we take a look at the concrete implementation of one of the observers, basically one of the subjects, which is our weather data. So our weather data is implementing the subject interface. It is maintaining a list of observers so that uh, it can call the update method on all of the observers when it is notified of the new value, real-time values. It also maintains this instance variables of temperature, humidity, and pressure. This will be used to get the values and updating the values. So on the constructor, in constructor, we create a new array, and whenever a register observer is called on the first time when an observer needs to be added to the list of observers, it will add at the end of the list. Similarly, if then observer needs to be removed from this array, or let's say list, it will be removed from the list. And then notify observers. So notify observers is a simple. We will iterate on the observers. We don't care whether it is display one, whether it is display two, or whatever, display X, Y, or display Z, whatever. We don't care what the concrete implementation is. We just know that this observers implement the observer interface. Hence, we just call the update method, and it takes in parameters of temperature, humidity, and pressure. So we send the new values to the observers, and measurements change. So this is what we need to implement. This is what we need to implement in this class as a dev. Basically, this was our challenge. So here, in previous implementation, if you remember, we did something like display one dot update, right? Display two dot update, which was very basically very not very much flexible, and also we were implementing to concrete implementation. So now we don't need this. We will just call the notify observers method, and it will notify all of the observers, right? So cool, right? Yes. And then we have set and getter methods for getting the temperature, humidity, and pressure. We have setter methods. So this is what basically sensor devices, when they get updated, they will call this method. Now, what are these sensor devices? This is we discussed, right? So if you take a look on our first diagram, this weather station, this weather station will call the method of measure, basically this one, set measurements, and it will set the temperature, humidity, and pressure. And once we update the new states for it, we call the measurements changed. Yeah, so this is the concrete implementation of subject. Now we will take a look at the observer. So observer is a simple interface. It has the method update. It takes in argument of temperature, humidity, and pressure. And if we take a look at the concrete implementation, let's say one of the displays. Also, if you take a look at the display interface, it has this display method. So if we take a look at forecast display, so it implements both the interfaces, observer and display element. It has the instance variables of the variable, basically for that will be used for basically displaying this forecast. So this is our constructor. In constructor, we take in the basically subject through to which we want to be registered for notifications. So in the constructor, we basically register as observers. And this is the method which we will implement of the observer interface. This calls the temperature, humidity, and with pressure arguments, and we update the state variables which we will use for display. So if you remember this up, whenever we get a real-time state changes, we will call our display method so that it also needs to be updated. So we update our display also. And also, you can take a look at all other displays, they'll be implemented similarly. So this is how the implementations look like. Now let's go back. So this is, we have completed the part of observer design pattern. Uh, from the problem to the solution and all the coding part. There is one extra page which we can discuss is push versus pull, basically for getting data, right? So our subject is, if you see in this diagram, this is our subject. It is pushing data. It is pushing data. Like it is calling the method dot update with temperature, pressure, and humidity. It is pushing the data to the displays, right? Pushing to display one, pushing to display three, two, pushing to display three. Now there is one another way of getting the state is via pull. So the pull mechanism is whenever we call the update method. So let's say we are calling the update method. Let me show you here. So yeah. So here we are calling update method with three parameters, right? You saw that we were calling update with temperature, pressure, and humidity. The subject was calling us observer with this. So it was pushing the data. It was pushing that take this temperature new value, take this pressure new value, take this humidity new value. So this was pushing. Now there is another way of doing this via pull is we don't send this value. So in pull we we just call dot update and we don't send any new value, right? We don't send any new value in the function call. So you will ask question like, then how will I get the basically updated values? Is that in the method, if I show you code implementation of it. So here, if you see, we are calling this temperature, humidity, and pressure. We are basically getting the data. It is getting pushed to an observer. We can remove this. So for this is implementation for pull. So if you see, we can get the newest temperature by just calling this dot weather data. That is our subject. On the subject, we'll call this method get temperature, right? So we can do this. It's a getter method, uh, and similarly, if I need humidity, I will call the get humidity, right? So unnecessarily, I don't have to basically push to the data I don't need, right? I can be flexible, right? Also, this is considered more suitable because here, if you see, our function signature is very simple. We are not dependent on the state, so we can basically update the state, right? Basically, we don't need to pass, let's say here, state one, state two, state three. If in future a state 4 comes, I need to pass that also. You see the problem here, right? If I need to remove a state, I need to remove it. Let's say I need to remove state 3, I will need to update it on all the observers and also our interface. So this is a problem. So to remove this problem, we can just use the getter methods of our subject. So this is considered more correct or more resilient approach of implementing the uh, observer design pattern. So both are correct. The push version and the pull version both are correct, right? So currently we were using push and we can let the observers fetch state whenever they get notified about change rather than we pushing the state to each observer, right? We can just use the getter methods. Also, if we change the update method, we won't have to modify it in all the observers. So this is the benefit we get. It makes our design more resilient. So you can use pull or push data from the subject when using this pattern. And generally, pull is considered more correct version or let's say implementation. Okay, so this is the final, basically our slide where this pattern is fantastic, basically learning because because it satisfy all the four design principles that we have discussed till now. So The first design principle we discussed was the identify the aspects of your application that vary and separate them from what stays the same. Right? We need to encapsulate what varies and we need to separate it from what stays the same. So here what we are encapsulating, we are encapsulating the number of states and the number of observers and also the uh, basically removing and adding of observers. So this is what we are encapsulating. And staying the same part is how we are getting notified. And second is program to an interface. This is second design principle and not an implementation. So as you saw, we were programming to subject interface and also observer interface. Third is favor composition over inheritance, right? You saw that we were not using any inheritance. Rather, we were maintaining a list of observers in subject, and so that in if we need to add any observer, we can just append to the list, and if we need to remove, we can just remove from the list. And also we should strive fourth design principle was we should this is what we learned in this while in this class is strive for loosely coupled designs between objects that interact. Okay, so we saw that our subject and observers they are loosely coupled. Why? Because they just know that they implement the subject knows that the observer implements this interface observer interface and the observer knows that it is implementing subject interface. So yeah, that's all, guys. This was the second episode, and I hope you learned a lot from this and you took the notes. And I will share all the links of the codes. These are taken as a reference from the head first design patterns book. I can show you here. So I'm learning from it also. So I'm sharing with you all. So I will share the links and all this presentation in the description. And also please share it and give a like, subscribe to my channel for the upcoming design principles. We will learn in this in detail. And hope you guys liked it and do comment and do share. Thanks. Have a great day. Bye.